Okay, so lesson 5, GCF and LCM. You can label your paper as so. And get down also these definitions I have here. For greatest common factor is the largest of two or more numbers that is able to exactly divide into both of them. And for least common multiple, the first or smallest positive number that is a multiple of two or more numbers. I like to use the word first. If you're looking for this definition, you will more than likely run into the word smallest. But pay attention to the words that I have in the definition underlined. For greatest common factor, I have divide, and for least common multiple, I have multiple. You can think of multiply. But my point of this is when we look at our example, I can better show you. So go ahead and have this down and then refer to this example from these definitions with me, please. Okay, so we're going to go ahead and jump right into the first example, and I'll explain what I mean with the divide and the multiple underline, excuse me. Okay, so we'll look at the greatest common factor first of 20 and 28. So you think of the word greatest, you think of a large number, but we had underlined the word divide. So what that means is that number probably isn't going to be that large, correct? Okay, and then when we look at LCM, I'll show you what I mean, but it says least. However, in the definition, we understand that we're looking for a multiple. If you're multiplying, something's going to be, things are going to get pretty big. So my point of that is just keep in mind that if you're looking for both the GCF and the LCM of this pair of numbers, the GCF is going to be a smaller number than the LCM, okay? So that's my point. Keep that in mind, please, okay? The LCM is going to be a larger number, and we will find both to this pair of numbers. So keep that in mind, but we will be going over GCF first, and I have 3 examples set aside. We will use the same 3 pairs of numbers for the LCM, though, so that you can see what I mean by that, okay? So let's use our factor trees here. Go ahead and think of 2 numbers that you can multiply that will equal 20. Now you could use 10 times 2. I'm going to use 5 times 4. Okay, 5 is prime, we know. We can't multiply 2 other numbers besides 5 and 1 to get to 5. So now let's break down 4 because we know 2 times 2 can get us to 4. Okay, so those are prime. Now let's work on 28. Multiply whatever you'd like. I multiplied 7 times, well, not whatever you like, but I multiplied 7 times 4, okay? 7 is prime, 4, we can multiply 2 times 2 again and get there. Circle those out, those are prime. Now, go ahead and line these up. For 20, we got 2, 2, and 5. Do these in order. 2, 2, 5. Now for 28, we got 2, 2, and 7. Circle out your common ones, and you will use that one time. Let me show you what I mean. Okay, so these are common, 2 and 2. Now 2 and 2 are common again. So what we do is we use that 2 and 2 one time, this pair of 2's one time. Okay? Now we don't worry about what is not common. Okay? So we just have 2 times 2 then, which equals our greatest common factor of 4. Okay? So the greatest common factor for 20 and 28 is 4. Okay? Make sure you have this so that when we go back later and look at the LCM, we see how it's a larger number. Okay? Now let's try the pair 35 and 49. Use your factor trees. Okay. For 35, I multiplied 7 times 5, where both are prime. Now for 49, I multiplied, think about that one, 7 times 7, okay, where 7 is prime, okay? So we are there at the bottom. Now let's see what we've got. Let's line them up. 35, we've got 5 and 7. 49, we've got 7 and 7. Circle what is common. We only have one thing in common, and that's 7. Being that we're not worried about what we don't have in common, we only have 7. And since there is nothing else in common, we cannot multiply 7 times anything else. Being that there is, again, nothing in common, we just use that 7 as our greatest common factor. Okay? Now let's try our last greatest common factor example of 150 and the number 225. Oops. Factor trees. All right, to get to 150, think about how you're going to multiply, or think about what two numbers you will choose to multiply. Either way, we're still going to get to the same numbers if you do these correctly, okay? So I multiplied 50 times 3, where 3 is prime. Let's keep breaking down our 50. Now, I multiplied 10 times 5. You may have multiplied 25 times 2. Perfectly fine either way. If 5 is prime, 10, let's keep breaking it down. We can get to 10 by multiplying 5 times 2. Circle those, they're prime. Now 225, go ahead and think about what two numbers you will multiply to get there. I used 25 times 9. To get to 25, I multiplied 5 times 5. To get to 9, I multiplied 3 times 3. Okay, all this is at its end. We are at primes. Okay, so now let's see what we have. For 150, we have in order 2, 5, 3, and 3. I said 2, 5, 3, and 3. My goodness, I meant 2, 3, 5, and 5. You probably caught that. Okay, now for 225, I have 3, 3, 5, and 5. Circle what is common, and we will use that pair just as that number. Okay, so this pair of 3, we will use a 3. This pair of 5s, we will use a 5. And then this pair of 5s, we will again use a 5. 2 and 3 right here are not common, so we just use what's common. We have 3, 5, and 5 common. So that's 3 times 5 times 5. And let's work that out. 3 times 5 is 15. My goodness, that does not look too presentable. 15. That's a little better. Now let's do 15 times this last number we have here, 5. Okay, let's work that out on the side. 15 times 5. 5 times 5 is 25. Put your 5, carry your 2. 2 times 1 is 5. Plus 2, 7. Okay, so our greatest common factor is 75. Okay, greatest common factor of 150 and 225 is 75. Go ahead and get that down for me. Alrighty, now let's find that LCM we mentioned. Let me go ahead and expose these to you all at the top. GCF for 20 and 28 was 4. The GCF for 35 and 49 was 7. And the GCF for 150 and 225 was 75. Okay, so remember that word from that definition, divide. I told you that if we're looking for both the GCF and the LCM of these numbers, that the GCF will be smaller numbers and the LCM will result in larger numbers. Let's see if I'm lying to you. All right, so let's find the LCM now. Now the LCM, what we will be doing is we will not just use what is in common. We will multiply all of the factors, okay? So let's again find it for 20 and 28. All right, so you can use the same. I multiplied 5 times 4 to get to 20. 5 is prime, 4, we multiplied 2 times 2. I'm kind of going to go a little quicker on these because we've, in a way done this. But what matters is this last part on what we do with these factors, okay? So for 28, I multiplied 7 times 4, broke down 4 to 2 times 2, circle my prime numbers, okay? So then our result, or what we are resulting in for 20 is 2, 2, and 5. I probably sound like a broken record. All right, 2, 2, and 7 for 28. Circle what's common, not because we're only going to use that, but because we just use that pair of numbers as that one number, okay? 2's in common, and this is a way I like to remember to do it. Okay, so unlike the greatest common factor, we are not just multiplying what's in common. We're using what's in common and multiplying as well the others, okay? So we have 2 times 2 times 5 times 7. So obviously this number will be larger than this number. 2 times 2 is 4. 4 times 5 is 20. Now let's go off to the side and figure out what 20 times 7 is. 20 times 7. 7 times 0 is 0. 7 times 2 is 14. So our least common multiple is 140. Alrighty, remember, it's going to be a larger number. So the least common multiple of 20 and 28 is 140. Alright, make sure you have that down. Let's try the pair 35 and 49 now. Okay, let's see. Okay. 35 and 49. Factor trees. I remember what those are called. That's a nice thing. All right. What two numbers are you going to multiply to get to 35? I'm going to multiply 7 times 5. Both of those are prime. That worked out nice. What about 49? What two numbers will you multiply? 7 times 7 seems on the money. Okay? So 7 is prime. Let's see what we've got. Ooh. Alrighty. This 7 is in common, so that means we have 1 7. But we have 5 and 7 still not in common, and that 7. We're going to multiply all of those. Okay, so 5 times 7 times 7 equals, well, what's 5 times 7? We know that that is 35. Now let's work out 35 times 7 over here. Okay, or yeah, 35 times 7. What is 7 times 5? 35 again. And 7 times 3 is 21, plus 3 is 24. I keep doing that. Our least common multiple of 35 and 49 is 245. Alrighty. I'm still thinking we're in GCF, but we are in fact in least common multiple, LCM. Alright, so let's do our last example of 150 and 225. Let's see. So this one was 245 for the LCM. Alright, so we have 150 and 225. Factor trees, please. Alrighty, so think of two numbers to get you to 150. I used 50 times 3. 3 is prime. Think of two numbers that'll get you to 50. You may have used 25 times 2. I used 10 times 5. Okay, 5 is prime. Let me break down this 10 with 2 times 5. Okay? Oh, I put 2 times 10. Goodness gracious. 2 times 5. 5 and 2 are both prime. Alrighty. Now for 225, what two numbers would you use to get there? I used 25 times 9, broke down my 9 to 3 times 3, 25, 5 times 5. We already know this. We did this with the greatest common factor, but we are using the same numbers for LCM, just because I want to show you the difference, okay? Alrighty, so now let's see what we've got. For 150, we have in order 2, 3, 5, and 5. Got that right this time. 2, 3, 5, and 5. For 225, we have 3, 3, 5, and 5. Now try to do this one on your own, and let's see where we end up, okay? I will still go through it. These 5s are in common, so we use a 5 to represent it. These 5s are in common, we use a single 5 to represent it. These 3s are in common, we use a single 3 to represent it. Now we have 2 times 3 times 3 times 5 times 5, okay? 2 times 3 times 3 times 5 times 5, okay? 2 times 3 is 6. 6 times 3 now is 18. 18 times 5 is, I actually know that one off the top of my head, but it's 90. And then 90 times 5, I do not know, so let's see, 90 times 5. 5 times 0 is 0. 9 times 5 is 45. Okay, so our least common multiple for this one is 450. Alrighty, the least common multiple of 150 and 225 is in fact 450. Alrighty, so before we wrap it up, I would just like to, oh, I should never erase this one all the way. Go ahead and make sure you have this down, okay? Just so that you can see the difference. So, what I would like to point out quickly is that the GCF, what we're doing is we are multiplying common factors. What we are doing with the LCM, multiplying all factors. Okay, so hopefully you have the definition in the beginning. That kind of explains why we got a smaller number. You know, we divide basically, and why we got the least common multiple as a larger number is because it's a multiple, we multiply. But when we use that factor tree and get down to it and we find those prime numbers, what we do is we multiply, or we are multiplying the common factors, and for LCM we are multiplying all the factors, okay? All those prime factors with the prime factorization method, and that's how that comes full circle.